For a given system of forces, we have to find out the resolution of all the forces in two different parts. First one is along the inclination and perpendicular to the inclination. That's the first question. Second part of the question is nothing but along the x and y axis as shown in the diagram. All right, so let's move to the first part of that. So this is along the inclination, right? So when they say we have to split the forces along the inclination, this basically refers to, right, the horizontal and vertical with respect to the inclination itself, right? Inclination itself can be considered in the following fashion. So this could be your x dash and this is your y dash. So along x dash y dash is what they are asking, right? So this is along x dash and y dash. This is what I need to split, right? So I just have to tilt this diagram, right, so that I can visualize. Now this is the x-axis, the normal itself is the y-axis, because normal makes actually perpendicular 90 degree with this. Okay, so that's the part of the question. Now I just have to split every force along the x dash and y dash. Okay, so let us consider the first force, that is F. I'll start with this, right? If you consider F, the F is actually making an angle. What is an angle made by F with the x dash, right? It is towards the negative of the what you call x dash, right? So what is the the component of F along x dash? F x dash is equal to, it is along a minus negative axis, so this is minus F, and F y dash, force along the y dash, is equal to 0 because it has no component, right? No component along the norm. Okay, that's the first part, right? You have to do this for each and every force. All right, let's go to the n now. So n along x dash, right, is it along x axis or y axis? It is along the y axis, right? So when you have a force completely along y axis, its x component is 0, but the normal along y axis is n itself. It is complete and it is positive. That's why it is, no sign has been written over here. Okay, let's move further. Let us write the T part now. So what is the tension along x dash? Tension along x dash is nothing but, x dash is this axis, so actually angle is given as 30 degree and the 30 degree is with respect to the x dash, correct? So I just have to convert the T along x axis. Since the angle is given with respect to x axis, this is T cos 30 degree. And what is the T along y dash? It is, right, T into sine 30. I can substitute the value of sine 30 cos 30 and I can simplify, or else even this is fine for us. Okay, then let's move further. There is another component W, right? Only thing which makes an angle with the x or y axis is this W. So how to find out what is the angle made by this W, right? So I can simply try to draw, right? This is the actual perpendicular. If I draw a perpendicular like this, right, I know that this angle has to be 30 degrees. So it is 30 degrees with respect to the y axis, y dash axis, right? So angle is given with respect to y dash, and you can see that this is in the third quadrant, right? Where are the quadrants? This is the quadrant 1, quadrant number 2, this is the third quadrant, and this is the fourth quadrant. So since it is actually present in the third quadrant, right, I am very sure that both the x and y components are negative. Okay, so let us try to write that. That is, this is W along x dash is equal to, it is minus W sine 30 degrees. All right, and the W along y dash is equal to, this is again negative W cos 30 degrees. Okay, so totally we have these 4 components, and they can be splitted, or they can be resolved into, right, x dash and y dash, right, along these components like this. So these are the answers for the first part of the question, that says along the inclination. All right, so let's move further, and we want to perform the similar analysis, similar resolution, but it is not along x dash y dash, it has to be along the x and the y axis. Okay, so let's just copy this diagram once again. All right, let's go down. So this is along the x and y axis now. So next part of the question, this is next. Okay, this is part B of the question, that is along x y axis. So what is the component of every force along this axis and along this axis, for which I need to find out what is the angle made by each of the forces along x and y axis. Okay, let us start with the F, right? So you can see that F is actually making it like this, and we know that this angle is 30 degrees because F and this inclination, they are parallel, right? So I'm using that concept now. So F makes an angle 30 degree with respect to x axis, and it is present in which quadrant? So if I try to make the x and y axis like, okay, let me just let's complete the 4 quadrant now, so that we can understand where are each of the forces located. So this is the extension for the second quadrant, and I'll also extend the y axis downwards. So because of that, now I can even right. So if you try to plot F like this, that actually if I extend that over here, this is in the 3rd quadrant, correct? So because of that, now it's very clear that the force is in the 3rd quadrant. So the F along x axis is nothing but, see, it makes 30 degrees with respect to x axis. So it is negative minus F cos 30 degree, and the force split into y axis. Whenever the angle is given with respect to x axis, I can find the y component by using, again, this is going downwards, so this is minus F sine 30 degree. So that is the answer for the resolution of F along x and y axis. Okay, next we have to consider the N. So N is like, see, N is presented over here, right? I'll try to write a parallel to N. So that will be something like this, right? You can see this is the N. Parallel to that will be acting here. Now where is it located? It is located in the 2nd quadrant. So, and if I want to measure the angle, right? So how do you measure the angle? Angle with respect to y means you draw parallel to y axis. So y axis is here, parallel to y axis is this. Okay, so again this angle will be 30 degrees. So with respect to y axis, this angle is 30 degrees. So this is the given case, right? So it is, its magnitude is N, and it makes 30 degree with respect to the y axis. So in such cases, the N along x axis will be going to the left, so negative minus N sine 30, and Ny, it is positive N cos 30. So we try to split this into x and y components, and we got this answer. Okay, then let us move the T now. So we want to calculate what happens when I want to split the T along x and y axis. All right. So let us consider the t now. So it's very simple now. You see, the t makes 30 degree with respect to x dash, and x dash makes 30 more degrees with respect to x. So if I want to measure this angle, this has to be 30 plus 30. So totally 60 degrees, right? So the t makes 60 degrees with respect to x axis. All right. So that should be very clear by simply looking at this. Okay. Okay, now let us try to write those components. Okay, so that means okay, so now we are trying to write this. That is a t. So t makes a 60 degree with respect to x-axis. So tx is equal to t cos 60, and the ty is equal to, what is the y component? This is t sin 60. Okay. All right, then let's move further. Now I want to write the last component, that is w. So if you see the w is actually along y-axis and it is negative, right? It's coming downward. So wx is equal to 0 and wy is equal to minus w, because it is completely present along the y-axis. So if you draw this, this is the w. So it is along the negative of the y-axis. So the answer is equal to minus w. So we can split any given force in this fashion. Okay, right. Now let's move further. Next, we'll define another quantity. This is also equally important. This is called as the moment of moment of a force. Now let us check, how do we measure the moment of any force? So in order to check the moment of a force, the magnitude of what you call as the torque is also known as the moment of the force, right? So how to calculate the moment of force, right? You can actually calculate by using the product. It's the product of the magnitude of force and its perpendicular distance. Along a perpendicular distance. Okay, I can write from, not along. So this has to be from. Distance you measure from the axis of rotation. So whenever you consider one of the point as a axis of rotation or a reference point, from that point, what is the perpendicular distance of the force that is acting on the body? right? So that's what is called as the what you call as the moment of a force. Okay, so this is basically denoted by, so you can call this as a it's a turning effect, right? So denoted by, normally C is the notation for this moment of a force. You can measure as a C, or even some of the textbooks will call it as a tau. Okay, it doesn't matter, it is which one you are into. Okay, let us look at the measurement now. Okay, and there is a sign convention, right? Let's look at the sign convention, but before that, let's try to draw a reference diagram for us. Okay, let's say this is a plane, and let me draw the axis of rotation, maybe through the center of this. Okay, say this is the axis of rotation, which actually passes through the center of the circle. All right, now let me assume that on this particular plane, I will apply two different forces. Okay, and the first force is acting in this fashion. Okay, so this is the force. I'll write this, I'll call this force as F1. And let me also apply another force that is somewhere here. Okay, I'm applying a second force. So let me call this force as say F2. Now, definitely when I apply this force, the object is going to start rotate, right? Because force is not acting at the center. So if I fix the center by means of say some string or something like that, it will start rotating, right? The same effect how the tires rotate, or the how the tires are going to rotate. At the center it is fixed. You apply force on the outside of the tire will start rotating, right? The same effect, right? So depending upon the direction in which you apply the force, there is difference, right? So let me draw a perpendicular distance like this. So for the first force, the perpendicular distance could be like this. Okay, for the second force, let's say there is another perpendicular distance that can be measured, and let me denote that perpendicular distance, say like this. Okay, so this is first showing that the angle is 90 degrees, and there is another one, this is also 90 degrees. All right, let me call the distance as R1, and the perpendicular distance for the second force from this point is say R2. Now, the direction in which the object is going to rotate will give you the direction of torque, right? So let's write a fundamental rule here. This is the convention, right? So I'll write the direction of torque. If I want to measure the direction of the torque, then I'm going to use the product, and I will identify whether the direction is indicated by positive or negative. For example, something which is rotating in anti-clockwise, right, that is considered as a positive. Okay, and something which is clockwise, right, so they are considered as right, the if it is clockwise, this is negative. All right, so I'll just mark. So if at all something goes like this, that is positive, and if something goes in the opposite direction, so that is this, it is negative. So positive and negative, right? So now you see, right, so the moment, the C is equal to F1 R1 is one moment, and it is positive because the F1 tries to move this in this direction. When I apply F1, it moves in the anti-clockwise direction, so it is positive. C is equal to plus R1 into F1 or F1 R1. At the same time, if I write C as C in terms of F2 R2, it is negative minus F2 into R2, force into the distance, right? But it is negative because when I apply the force, it is going to rotate the object in the clockwise direction. So the convention I'm going to write here, right? So the convention is, if you have clockwise rotation, right? So the clockwise rotation is negative. Anti-clockwise, right? Rotation, we assume it to be the positive. Even if you reverse, what happens? Nothing will have changed, right? So you can definitely make, it's a convention. Convention is in the sense, right? You can change it as in when you want, right? So, but for a given problem, you don't change the convention in the middle, right? So when you start with a particular convention, apply the convention throughout, right? Whichever problem you are solving, apply the convention throughout that problem. Okay, so that's what is meant when we say the convention is like this. All right, so let us apply this and find something. Okay, now let's move further. Let's analyze this in the form of a problem. Consider a square of sides 2 meters and O as its center. The forces along each side is as shown, right? So find the moment of each force. Body of the question about point A, part B of the question about point O. So this is the given diagram. So this is a square, let's assume each one is of a specific size. Okay, so the sides are 2 in nature, so 2 meters. So this is A, B, C, D. Okay, so it mentions that there is a 2 Newton force here, there is a 5 Newton force here, there is a 4 Newton force here, and another, this is a 3 Newton force. And at the center they are marking, okay, so this is the point, this is the point O. All right, now the question is that find the moment of each of the force, right? About first part is point A, then second part is point O, right? If you consider the rotation is happening at A, what is the moment? If the rotation is assumed to happen at O, what is the moment of each of the force, right? So first, let's try to answer the part A. This is we are trying to find the moments about the point A. In the sense, let's start with each of the force. There is a force along AB, right? Force along BC, force along CD, force along the AD or D, right? 4 forces you have. I just have to measure the force into the perpendicular distance of the force from A, right? Let's go for the first part. This is very simple. Say 2 Newton. For a 2 Newton force, the moment about that point A, MA, I'll denote it as MA, right, is equal to, what is the force? Force into distance, right? So force is equal to 2 Newtons. And what is the distance of the force from A? See, the force is actually passing through A. Whenever the force and the point coincide, the distance is 0. There is no perpendicular distance because it is passing through the A itself. Consider the previous diagram. You can see if at all the force was passing like this, right, F1 is like this, there is no perpendicular distance. R1 is 0 there. So the moment becomes equal to 0 in such case. Okay, so the first part is that. So the force A passes through this. So 2 into 0 equal to 0. There is no moment. Similarly, you can see that even there is a 3 Newton force which actually passes through A. So the moment becomes equal to 0 for that. Okay, so then I'll write the 3 Newton force, right? Once again, the moment about A for that 3 Newton is equal to 3 Newtons into distance is 0, so 0. But it is not 0 for the other 2 forces like 5 Newton. So the 5 Newton force, if you want to calculate, right, the moment about the point A is equal to, what is the force? Is 5. What is the perpendicular distance? So you see, this is the line of action. This is perpendicular. So this distance is what I need to consider. They already have mentioned that the side of this particular square is 2 meters. So 5 into 2, right? So the perpendicular distance becomes 2 meters, right? Because of which, now you know that the value becomes equal to 5 into 2. So that is 5 into 2 is equal to 10. But you see, I have to specify what is the direction, because plus or minus will come into picture. Now you see, this is the distance and I am applying the force like this because 5 Newton is coming downwards. So what happens if you consider this as the center point, right? If you consider this as a center point, this is going to rotate in which direction? It is going to rotate in the clockwise direction, right? So this is along the clockwise direction, so it is negative according to this. So minus 5 into 10, so minus 10. Force is in newtons and distance is in meters. So unit for this is force into Newton. So Newton, force into distance, so Newton meter. Okay, so that's how you try to identify the sign, right? Apply the sign convention. Then we go to the next one, that is 4 Newton, right? So moment about A for that particular force, 4 Newton is nothing but force is how much? Force is 4. What is the distance? Now the distance you are going to consider is this distance. Again, every side is same for a square, right? Because of which now you can say that the perpendicular distance is once again 2 meters. So 4 to 2 is equal to 8, that is fine, but I need to specify the angle as well. So how do you apply the angle? You see the force is actually acting like this, that is CD. And from A, if you measure the perpendicular distance like this, so this is going to rotate in which direction? It is the anti-clockwise direction, right? So anti-clockwise direction means it is positive. So you don't have to put a sign over there, right? Anyway, so that is equal to how much? 8 newtons. 8 Newton meter minus 2. Okay, so let's just do that. So this is plus 4 into this, so 8 Newton meter. All right, this is part A of the question. Right, let's move to the part B of the question, for which now we need to measure the same moment, but it is not along, not at the point A, but it is at a different point. So I'll just paste it here. Okay, so we got it. Then now let us try to so I'm trying to answer the part B of this question. The moments about not B, sorry, moment about O. Right, now I need to find the distance of what you call each of the force, right, from O itself, in the sense the 2 Newton. Let's do with this. So for first we'll start with the 2 Newton force. Okay. 2 Newton force, the moment about O is equal to, what is the magnitude of the force? That is 2 Newton into, I want the perpendicular distance, right? What do you mean by the perpendicular distance in this case? In this case, that is the distance between the O and this 2 Newton, correct? It is nothing but half of the side of your square, right? So each side is 2 meters, so distance is 1. Okay, now I need to identify what direction. So, right, if O is this point and you apply the force like this, think that along the shortest distance you are holding a pen. So if I apply the force to the, you hold this, right? This is the fixed point, right? Wherever you are considering, there is a fixed point. So this point is fixed now. When I have fixed point over here, this is say fixed, and this is the force. Just consider what is the direction in which it is going to rotate. It will rotate like this, right? So that means it is, right, clockwise or anti-clockwise? It is anti-clockwise. So whenever you have the rotation happening in the anti-clockwise direction, anti-clockwise direction means positive, so this is simply 2 Newton meter. Right, let's go for the 5 Newton case now. So moment about O is equal to, force is 5, distance is 1. I just have to identify the direction. So now you see O is here. I'm holding the pen like this and I'm applying the 5 Newton force downwards, right? So this means it is going to rotate in the clockwise. So as per our convention, the clockwise rotation is negative. So this is minus 5 into 1. So minus 5 Newton meter. Right. Similarly, go to the 4 Newton case. Right. The 4 Newton force acts between C and D, and it is right towards left. So anyway, distance is 4 into, force is 4, distance is 1, 4 into 1. And I can observe that if I hold a pen like this, it is going to rotate your pen towards the left. Left indicates it is anti-clockwise. So the anti-clockwise is positive. So this is 4 into 1, that is 4 Newton meters. Then the 3 Newton force. For a 3 Newton force, I have to hold the pen like this, apply the force in this direction, keeping O fixed. So when O is fixed, right, the pen is going to make clockwise rotation. right? So because of that, the moment about O clockwise is negative, minus 3 into 1, so minus 3 Newton meter is the answer. So you see, as we change the reference point, right, we get different answers. So first part is different, second part is different. You can actually extend this and measure the moments about B or C or D as per the requirement. Okay, so that is this question. Let's move further. This is a problem to solve. W, X, Y, Z. So they have given the sides. This is 12.85 meters. (8.96 meters), and the forces are marked like this. So this is 12.86 Newton, 17.78 Newton, 29.36 Newton. This is 8.93 meters. So the question here is find the moments of each of the force. Part A of the question about Y. Part B of the question about the point where diagonals meet. Okay, wherever both the diagonals meet in this particular shape, find the moment of all the forces about that one. It's something like the O, right? If you look at the basics, so there will be a point at the center where both the diagonals will meet. So that is actually somewhere here, the center point. Even you can mark that point and call it O. So the MO is what is asked. So the let's write with respect to okay, this is part A, okay, and I'm writing for 29.36 Newton. For this force, the moment about Y is equal to this is 29.36 into the distance, and the distance is shortest distance is 8.96, correct? So what is this answer? This is equal to 263.06 Newton meter, and I need to decide whether it is positive or negative. So right, this is going to rotate the object in the anti-clockwise direction, right? So this is positive. That's the right answer. Then the 17.78 passes through Y, right? So 17.78 Newton if you want to write. So that makes the moment to be equal to 0. right? So moment about y is equal to 0. Same thing happens with the other force on the top, that is also going to pass 12.86. Okay, passes through y. The 12.86 Newton, it actually passes through the y, so my is equal to 0. Next we are calculating for 8.93 Newton. So the moment about that y is equal to the force 8.93 into the distance. Distance is now 12.85. And what is the direction? Direction is anti-clockwise. Is it? Not anti-clockwise, clockwise. It's clockwise, so negative, right? So this is minus Newton meters. All right, that is right. So part A of the question is right. Part B. So this is with respect to the center of that particular shape. So let's call that as O, right? Let's write the moments about each one of them. So 29.36 Newton. This force, what is the shortest distance, right? From the center point, it is the actually, right? If you want to calculate that 29, so this is this distance. So distance is the 8.96 divided by 2. Right, so that is the shortest distance, right? 4.48. Perfect. So about O, it is going to rotate it in the anti-clockwise direction because of the direction mentioned over there. 29.36 is going to act towards the right, so this is going to make the object to rotate in the anti-clockwise, so positive, right? So 29.36, the moment about O is 29.36 into, what is the distance? 4.48. 53 Newton meters, right? Since it is anti-clockwise, it is positive, right? Then let's write for the second force, 17.78 Newton force. Okay, give it the answer. M equal to 79.65 Newton meter. Is it positive or negative? Positive. Okay, the next one is a 12.86 Newton. (57.61 Newton meter). Is it positive? So negative. This is minus 57 point. Okay, then the last force, that is 8.93 Newton. Minus 40.00 Newton meter. Perfect. Okay, then okay, next question. This is a homework question, right? So find the moments of each force about A. Okay, let me add a question of each of the force about there are 2 points about A and B. Okay, this is the point which we call as the point A, and this is the point which we call as the point B in essence. Okay. This is 17 Newton, making an angle of 135 degrees. Okay. This is 30 Newton. This is 75 Newton, 45 degrees. This is 60 Newton. And this force is 10 newtons. Okay, starting from 17 Newton till 10 Newton. Okay, now the distances are also given. Okay, this distance is 1.75. Then another distance given, this distance is 1.08. Then another distance is 4.35. This distance is given 1.35. Right, every distance is in meters and every force is Newton. So find the moment of all the forces. There are 5 forces shown, and you have to find the moments of each of the force, first about A and then about B. So this is the question.